Hello. So what we're going to do right now is I'm going to try to explain to you how to make the teensy control servo motors. Okay? And I have two of them hooked up right now for demonstration first. This one is a standard servo motor that is unmodified. It is as it would come directly from the box. And what makes it different from this one can only turn about about 180 degrees at most. It can only go from, say, here to here. All right, that's as far as it can go. This one is what's called a modified servo, or now they're actually called continuous rotation servos because they're actually made from the factory this way. It used to be we had to modify them. And it's able to go 360 degrees. Okay? Now, there's a really important distinction besides the fact that this one can only turn 90, this can go 360. This one always knows where it is. Okay, there's a potentiometer in there, a little variable resistor, and when it moves over, for example, this direction, it takes a reading from the potentiometer and it says, oh, I'm at, say, 100 or 1,000 ohms. And it knows that I'm over here. Okay? And then when it moves over here, it goes, oh, I'm at 1,800 ohms or 2,000 ohms or whatever it is. And it knows where it is. Okay? It's got a variable resistor inside of there that's hooked to the center spine. So it always kind of knows where it is by checking the resistance. This one does not have a variable resistor anymore. In fact, it has two fixed resistors of the exact same value that tie into the middle. Okay, so one side of that resistor series has got the same resistance as the other side of the resistor series. So bottom line is it always thinks it's on center. If it asks the question, oh, what's the resistance? Well, it's the same on both sides. I must be in the middle. All right, and it always sees it as on center. This case, it's only in the middle when it's in the middle. Okay, when the resistance on this side of the potentiometer is the same as this side, it knows it's in the middle. This one always thinks it's in the middle. So what that means is, and I'll explain it a little bit more when I show you the pulsing, is that if you send a signal that tells it to go to the middle, and it already thinks it's in the middle, it doesn't move. All right. Likewise, this one too. If it's in the middle and it thinks it's in the middle, it doesn't move. All right. If I send a signal to this one that says, oh, move it over here, well, it does move over there. And once it gets there, it stops. If I send a signal to this one and say, I'd like you to move counterclockwise over to 90 degrees off center, well, the wheel starts to spin, but the resistors never allow it to change, so it just spins and spins and spins and spins and spins. Okay? And in this case, if I do, let's say, for example, I want to move it to just slightly off center. So I want to move it to, I don't know, 85 degrees or something. And I send a signal to do so, it moves 85 degrees and it stops. This one, well, it thinks it's at 90 degrees. It thinks it's right there. And you're telling it to move there. It says, well, that's pretty close. Okay, I can get there, but I don't have to move very fast. So it slowly tries to get to 85 degrees, but it never gets there because its resistors say it's always stuck on 90. So it continuously, slowly moves. Okay? Well, let me show you some code here first as an example. What am I actually talking about? How do I send a signal? All right. Well, the way it works is it uses a pulse width of between 1 and 2 milliseconds with a 20 millisecond dead time. Okay. So if I send a 1 millisecond pulse and then a 20 millisecond delay where it's off, that'll tell the servo motor I want to be over here. Actually, I should say it depends on the manufacturer. Some of them tell it to go over here. But for the example of this case, it tells it to go to 0 degrees. Okay, I want to go to right here. If I send it a 1.5 millisecond pulse, that tells it to go right in the middle because it's only going between 1 and 2 milliseconds, and it goes to the center. If I tell it to go 2 millisecond pulse with that same long delay, it tells it to go to the 180 degree position. All right, so I've written some really lousy code right here, and this is just to start it off, kept it super simple but very bad. I have these two servos hooked up to pins 0 and 1. Pay close attention. The lightest color wires, are closest to the teensy. Those are on the signal pins. The red wires in the middle are on the center row of pins, which is going to be the supply, and the outer one is on ground. I am running this on a battery pack, although actually I'm running on this VN, so I have it set on VN, so it'll move very quickly if I want to. It is powered by a battery pack, and I can turn on and off this side of the board to power to this side of the board by utilizing this switch. Okay, it is now off, lights off, that lights off, it's now on, that lights on. Okay, real simple code here. Okay, nothing to it. I didn't even create any variables or anything. I'm telling pin 0 and pin 1 to be outputs. Okay, 0 and 1. I want those to be output pins. I am now going to send a digital write to both 0 and 1 to make it high. I'm going to wait 1,500 microseconds, which is the same as 1.5 milliseconds. And then I'm going to go send it low, and I'm going to wait 20 milliseconds. Notice the difference, microseconds, milliseconds. Okay? And if I run this, actually, well, nothing much is going to happen. Because remember, 1.5 from that other graph is the middle. 1.5 is 90 degrees. 1.5 is 90 degrees, and that means to this one to be in the middle, and it already syncs there, so it doesn't move. Now watch this. I'm going to go, let's go something dramatic. We'll go 2,000. Okay. So now I'm sending a 2,000 microsecond pulse, or 2 millisecond pulse. And notice they did spin in opposite directions. Like I said, manufacturers are different. This guy is moving very, very quickly counterclockwise. This guy went as far as it could clockwise. I'm now going to bring this down to 1,000. And should go. Come on. Oh, let me reset this. Oh, there it goes. All right. So now it's going as fast as it can clockwise, and this guy went as far as it can to counterclockwise. And it's not moving anymore because it's there. It got there. It doesn't need to move anymore. It's done. It's stopped. Okay. This guy thinks it's at 1.5 and never gets there. Let's try something that's close to 1.5. Let's try 1,400. Okay. So now we're kind of close to 1.5, which is center, so you expect it to go near the center. But you also see that this guy moves slowly. Okay, it never quite got the center, and this is moving slow. Let's move this to 100 microseconds onto the other side. Let's go to 1,600. We should see this guy move slightly over to this side, and this guy moves slowly counterclockwise. Okay, and then I will go 1,500 again, and it should move to center, and this guy will simply stop. All right, so let me write some better code, and I'll be right back with you. Okay, so here's a little bit more complete piece of code. Much of this I've copied and modified slightly off of Chris's text. But you can see what I've done here is create some variables to hold that basic information. Remember, 1,500 was a stop. It was either 90 degrees up on this guy or a stop on this guy. 1,000 or 2,000 were maximum speeds, either clockwise or counterclockwise. And then the closer we got to 1,500, like 1,425 and 1,575, those were slower rotations, either clockwise or counterclockwise. I still go ahead and put the pins to output. And let me go down here to the sort of the main portion of this, the create pulse. We're only going to take in a singular argument, which is that pulse width, that 1,000 or that 2,000, that 1,500 or whatever it is. And that is going to then take that pulse width and insert it into the delay microseconds. So whatever value I have here is going to get carried down to here. It's going to set the continuous, in this case I called it the content servo, the continuous rotation servo, that one. is going to go high, and then it's going to pause for that period of time, and then it's going to go low. Just one pulse. Okay. These other two functions, what they do, this one is continuous rotation. Okay, so it gets it stuck in an infinite loop, and it's simply going to call that pulse over and over again with that 20 millisecond delay. Okay, and in this particular case, we're going to run a for loop that's going to count down the number of steps. So I can put 100, 200, I can put 35, it doesn't matter. It's going to count down the number of steps. It's going to send a call to the create pulse with the pulse width handed down with the delay, and it's going to cause it to rotate. All right. So here I actually made some calls to it. Servo step, I want these two right here. You can see I'm going to call 300, 200, 200, and 300 steps. And then I'm going to send with it the speeds and directions that I want, which are dictated up here. Okay, 1000, 1425, 1500, whatever it is. For the moment, I've actually taken out stop, so it's going to run these four. Then it's going to go a continuous. Okay, if I want to, I can bring that stop back. In fact, I will, because it'll drive me crazy. But let's run this and see what happens. We should see it go 300 steps clockwise slow, then 200 steps counterclockwise. So there we go. So that should take about 6 seconds. Okay, 3,000, there we go. And then it does its counterclockwise pass, it switches directions, and it's going to end now with another slow rotation. I was saying this would take about 6 seconds because they're 20 millisecond delays times 3,000 or 300 is 6,000 milliseconds, or about 6 seconds. And now it's stuck here on this continuous rotation. Let me go ahead and pull that out. We'll reload it because we'll want it to stop. So now it's going to send a 1500 when it gets done here, which of course is the center line, which is what this thing thinks it's at all the time, and it's going to stop. So it'll do these four and stop. And it won't go here ever, because if you look at continuous rotation, it enters a while true loop, so it never escapes this. Let me add a little bit more, and I'll see you in a second. Okay, so in this last demonstration, you're going to see that I've taken and copied a piece from Chris's book about changing speeds. And in this case, we're going to step through all those pulse widths between 1000 and 2000 in increments of 10. Okay, so we're going to go from 1000 to 2000. We're going to hand that off into the servo step function. And then the servo step is going to reproduce that for 20 intervals. I'm sorry, that's what we call it up here, right? Yes, 20 intervals. It's going to count down for 20 intervals. It's going to send out that pulse. And notice here I've actually called back in this servo. So it's going to turn both of these. So we're going to see one go up and the other one do a rotation. Let's get it started because we're running out of time. So we're going to load it up. And it's going to start at 1000. All right, you can see this one slowly clicking up. And here you can see the values actually going up by tens. This motor is getting slower and slower as it approaches the 1500 point. And this one will be straight up at that point. Okay, so it's actually dead stop for about maybe 40 or 50. And now it switches directions. This guy continues to move in this direction because now we're on this side of 1500. And the last thing it's going to do is go to the servo stop. But keep in mind, that's 1500. So we should see this guy shoot to the middle right in its very last step. And there you go. So I'm going to end this right here and talk about robot motion in the next video. I'll see you soon.